Good morning. This is Mr. Behringer, and today we'll be working with geometric sequences. In any sequence, you want to always identify your first term. In this case, our first term is 2, and we represent our first term by a sub 1. Okay. Next, we want to figure out either the common difference or the common ratio between our terms. Now, to get from 2 to 6 would be plus 4, but 6 plus 4 would not be 18. Therefore, we're going to check multiplication. 2 times 3 is 6. 6 times 3 will give us 18. So our common ratio, also referred to as a constant multiplier, is times 3. Now we have 3 equations that we must go through in order to satisfy geometric sequences. First is the next equal now. In order to do the next equal now, we have next equal now, and to get from our now term, we have to multiply by 3. This satisfies our next equals now notation. Next is our geometric sequence notation. As you see, the geometric sequence is a sub n is equal to a sub 1 times our constant multiplier or common ratio raised to the n minus 1 power. So we just plug in the information where it fits. The a sub 1 term was 2, and our constant multiplier or common ratio was times 3 raised to the n minus 1 power. This satisfies our geometric sequence. Next is our function notation form. Function notation form is where we're going to take our geometric sequence and we're just going to change a few things in order for it to fit our explicit form or our function notation form. So f of x replaces the a sub n. We keep the a sub 1 term, and we keep the constant multiplier, which is 3. The n changes now to an x, and it's still minus 1. But what we're going to do is we're going to simplify this equation. All right? 2 times 3 to the x, and we're going to break this exponent apart here to be 3 to the x times 3 to the negative 1. Because multiplying two bases together is just combining the exponents. Now, with a negative exponent, you've been taught the negative exponent changes to its reciprocal, so this part here becomes 1/3. We keep everything else. All right. And now we combine like terms. The 1/3 and the 2 are considered like terms, and we're going to multiply those together. And by multiplying those together, we now have 2/3 times 3 to the x power, thus creating our function notation form.